Okay, Max, so I'm answering the question, if the half-life of something is 5,730 years, so then you kind of know that y, or the amount after a certain amount of time, is the initial amount. So sometimes we say a initial, that's a constant, times, and since it's the half-life, I'm going to put half as my base, and we're going to raise that to the t over 5,007, because it's 130 years. Because then if I plugged in t for 5,030 years, then it would be 1/2 of the original amount. So that's my equation. Now you wanted to know if the half-life of something is 5,000, and 74% is still here. So that's the relationship between A of O, A initial, and Y of T. So when you divide this by A initial, you divide both sides by how much you have left right now at that certain amount of time. This number is going to be 74%, because that's what it says. So I'm going to put 0.74 equals 1/2 to the t over 5,730. Now you could just hit the solve button on your calculator, and if you do this on your calculator, so I'll just change the color here, go to green. If you hit the solve button, and you know how to do that, solve for t, you'll get t, the time is 2,489.13 years. And that's how old it is. So you could, I don't know if your teacher likes to, so I'm going to just take this and make it a little smaller, move it up to the corner here. If your teacher wants you to do this by hand, I'll show you, you can get a little further by hand. You still need a calculator. You can say, take the natural log of both sides. So the natural log of 0.74 equals the natural log of 1/2 to the t over 5,730. And then you know your properties of logs. This is going to swing down. So then you have the natural log of 0.74 equals t over 5,730 times ln 1/2. So t is 5,730 times the natural log of 0.74 all over the natural log of 0.5. And you can go to the calculator there, put that in, and again you'll get 2,489.13 years. That's how old the thing is when you'll have, if 75% is left.